for this, again, like I said, there's not really wrong answers here. But there's some that are going to be easier than others. On this first one, we can see this is one of those perfect square trinomials. So I could really, really easy solve this using the square root property, where I put it as that perfect square trinomial and square root both sides. So this is where we square root both sides of the equation. That's what they mean by square root property. It's also, I could very easily set it equal to 0 and use the quadratic formula. Totally fine. I could also set it equal to 0, and I believe it would be factorable. No, it would not be factorable, so we're not going to put factoring. For number 2, this one is going to be best with, we could factor it, -7 on both sides. So we should be able to factor that one. We could also complete the square on this one. It's set up really nicely for that. We would just have to figure out what we would have to add in here to make it be a perfect square, in which case then we would use the square root property. We could also set it equal to 0 and use that quadratic formula. Three is the one that is super duper best set up for factoring. Multiplies to be 12, adds to be -7. We can do that. We could also use the quadratic formula here. It's already set equal to 0. I would not recommend completing the square or square root properly because -7 is going to give us fraction stuff when we complete the square, which is super gross. And then the last one, this is a difference of squares. So doing this as factoring would be good. We could also do this with the quadratic formula. Notice that we never once solved with graphing here. Solving with graphing is a least accurate method. And generally, I don't even provide you with graphs. If you love graphing, you absolutely can. It's very similar to quadratic formula. You could. It's just not nice. It's hard and finicky, and you have to be very, very careful. So I generally do not recommend solving by graphing unless we specifically ask you to. But you could make any of these methods work. Any of them are fine. They might be grosser than others. If I tried to use square root property on number 3, it's going to be a whole lot of work for it and square root stuff. But it could be managed. It's just going to be gross. Okay, so you can use any of the options. Quadratic formula works for everybody, but you have other options. Okay, so today we are going to do our last new stuff of the chapter. Last stuff. And it is called nonlinear systems. We've done systems of equations. It's where we took our two lines and found out where they crossed. We took two lines and found out where they crossed. We would do our substitution or our elimination to figure out where the two lines crossed. So now I have a line and I have a quadratic. And we're going to find out where they cross. It's the same thing. So we're looking for the point where these two equations cross. So the whole goal of a nonlinear system is to find the point or points. There might be more than one. So I'm going to put point and parentheses S. I'm going to put intersection. Find the point or points of intersection. Finding the points where they cross. The places where they cross. Oop, that's not what I meant. So our two equations here are 2x squared minus 3x plus 1 equals y, and y equals x minus 1. So write the equations down, and then we're going to think back to when we did systems of equations. Yes, dear. We're going to think back to our systems of equations and how we would solve with substitution. Well, I have that y equals x minus 1. I can substitute that in place of this y. So what we're going to do is we're going to take 2x squared minus 3x plus 1 equals x minus 1. And we're going to substitute that in. I'm going to fix that one because that looks weird. There we go. And we're substituting that in place of the y. Now we're going to solve for x. So I need to find my solutions, my roots, my zeros. What do I need to do to be able to find my solutions? We need it to equal what? 0. So what can I do to this thing to make it equal 0? Subtract x on both sides. And what else? Add 1. So that's going to give us 2x squared minus 4x plus 2 equals 0. You okay on that part? What can I do next? More specific. GCF. What's our GCF? 2. Because you're not wrong. I just want us to be a little more specific. So we've got a GCF of 2, leaving us with x squared minus 2x plus 1 equals 0. Then what? Divide 2 on both sides. Absolutely valid. Since we're solving, we're not looking to get this into a factored form. We can divide by 2 and get rid of them all together. X squared minus 2x plus 1 equals 0. Now what?
Take the square root.
Can't take the square root right now. You could quadratic formula it. That's fine. There's an easier way. Factor it. A times C is 1. My B is negative 2. What's a pair of numbers that multiplies to be positive 1 and adds to be negative 2? What multiplies to make 1? 1 and 1. And since we're adding to be negative 2, they're both negative. So this is actually a perfect square trinomial. So this is my x minus 1 squared, or x minus 1 times x minus 1. So what's my solution? What is my x? Positive 1. We don't even have to square root both sides and then set each term equal to 0. You can. You could also write this out in that factored form where it's x minus 1 times x minus 1 and do it that way. However your brain likes to do it, that's totally fine. No matter what, we're going to wind up with x equals 1 as our single solitary answer. So how would be that we're looking at this piece here. This piece, if we set it equals 0, x plus 1 equals 0. Or x minus 1 equals 0. Add 1 equals 7. So it's that piece there. But that's not our whole answer, because remember, we are looking for the point of intersection. The point where they cross, which means I need to find the y value. And I have two equations that I can use up here. You can use the top one if you want to. Bottom one's way simpler. We're going to have to substitute it in to find that point of intersection. We're going to take our y equals and substitute in our x that we found. I found that purple 1 down at the bottom. Minus 1. What's the y value of my point? 0. So our solution is the point 1, 0. So we're going to substitute the equations together, set it equal to 0, solve it however you wish to get your x's, and then you're going to take your x and plug it back in. So we're adding a step at the beginning and a step at the end, but the solving part is still the same. What this looks like is this is looking at a system of equations where we have, and it's this one. There's our parabola, and there's the line. So we're looking at where these two shapes crossed, and -1 or 1, 0 is exactly where they crossed. They're touching at 1, 0. So you can do it with graphing. It's just obnoxious to try and graph it and figure out where they cross, because we have to be really good. Okay? So that's what that looks like on a graph. It's a parabola and a line. We're going to do another one of these. Shock, right? So we got this one. X squared equals y plus 5, and y equals x plus 7. We're asked to figure out where they cross. We are told to solve the system. So x squared equals y plus 5, and y equals x plus 7. And what we have here is, once again, I have a y equals, I do not like that as a highlighter. There we go. I have my y equals this. So we can bring it up here and we can substitute it in place of this y. So we're going to have x squared equals x plus 7 plus 5. Substitute the chunk in. Are my blue parentheses actually doing anything here? No. But it's a good habit to be in. So what we have is x squared equals x plus 12. Yup. And now we're trying to solve this. What do I need to do first? You could subtract the x squared, but then that gives you a -1 as an a value, which generally makes factoring harder. So instead of subtracting the x squared, which would get us to equal 0, let's move everybody else the other direction. You're not wrong, it's just harder. So I'm actually going to subtract x from both sides, and I'm going to subtract 12 from both sides. My 5 and my 7 I added together to combine my like terms. These two guys.
No, I'm talking about, did you put it again right next to the thing on the far side?
Oh, I'm subtracting 12 from both sides because I want it to equal 0. So we're going to have x squared minus x minus 12 equals 0. The whole goal is to get it to equal 0 so that I can solve this some way, shape, and form. How do you want to solve this? Factor. Let's see if we can factor it. Let's make our x. A times c at the top, 1 times negative 12 gives me negative 12, which I'm going to do in a different color. And my b at the bottom of negative 1. Is there a pair of numbers that multiplies to make negative 12 and adds to make negative 1? 3 and 4. But which one's going to be negative? I heard debate. Yeah, the 4. Because I need it to add to be negative 1. So the bigger number is going to be negative. So from here, we can put it through our box. With our x squared from our equation, our minus 12 from our equation, and then the numbers in the x frame are just how that middle term splits, my 3x and my minus 4x. It's been a hot minute since we factored. So just to remind us, pull your factors in columns and rows. It's going to give us a factored form of x plus 3 and x minus 4. When you pull your factors in columns and rows, those are the factors that you're going to get. So what are our solutions here? Yeah, x equals negative 3 and x equals positive 4. Those are my x values. Those are not my answers. To get my full answer, I need the point of intersection, or in this case, the points, because we have more than one. So we're going to take those values and substitute them back into one of the equations. Which equation do you want to use, the top one or the bottom one? The bottom one, I recommend strongly. You can absolutely use the top, but you're going to be squaring stuff and then solving. The bottom one is plug and chug. So we're going to take our, I'm going to do this over here to the side. Y equals negative 3 as my x plus 7. And we're going to do y equals 4 plus 7. We have to do both. Substitute in both x's. So for this purple one, what is our y value here? 4. So one of our solutions is the point negative 3, comma 4. How about on this right one, the blue one? 11. So our solution is the point 4, comma 11. And it's 2 points. These are our solutions. If we see what that looks like, take us over to Desmos again. Come on, turn on. These are our two equations. Here's our parabola, and here's our line. And our points of intersection, we've got negative 3, 4, And we've got 411. So we did it exactly right. It's fine to use a graphing calculator to check this, especially if you're working on one like on homework. Feel free to use Desmos to check it. We did just fine here. I am only going to give you systems that are a parabola and a line. I will never give you two parabolas because the math on that is really annoying. Okay? Sometimes we're just going to give you a picture. I didn't print this out because we're just going to look at it. So you could absolutely come up here and algebraically solve this. You could do it. We're going to wind up with whole numbers. We can also just look down at the picture here. So if you're just given a picture, just look at the picture. Where are my solutions? Yeah, we've got our, that was chunky, our 1, 5. And then, yeah, exactly right. Our, boop, this guy up here. 5, 21. So if you are provided a picture, read the picture. We could algebraically solve it, totally fine. We've done that. We did it twice already today. But if you're given a picture, use the dang picture, make your life easier. We are going to do one more of these, and it is the hardest one, okay? So here's our equations. We have y equals minus 2x plus 2 and y squared equals 2x. This one is the hardest one that we will have. It doesn't change what we do. We're still going to substitute in my y equals in place of the y. We just have to be really careful because my y equals this is going into the piece that's being squared. So when we write this out, this is part of the reason I always substitute in parentheses, because this is negative 2x plus 2 squared equals 2x. And then we need to be very careful that we do the right thing next, because our next line is not 4x squared plus 4. It's not. You either need to box it or write it out and do double distribution. I'm going to do the distribution thing because it actually takes up significantly less space than a box. But remember, it means to be squared 2x plus 2 times negative 2x plus 2 equals 2x. That's what it means to be squared, is to multiply against itself. And we can start to see here, hopefully, that it's not going to be a 4x squared plus 4. Because we're going to have our minus 2x times minus 2x, where we get 4x squared. So we do get that piece. But then we get minus 2x times 2, and we get minus 4x. And then I got to do my second term, 2x times minus 2x, and we get minus 4x. And then one last piece, this 2 times that 2 to get plus 4. So it's really important that we remember how to square things. Does everyone see how that happened? Because I've seen that a lot of times in the Algebra 2 homework where we'll square something and we'll just like distribute through the square, and that's not what it is. Because when we combine these like terms, what we get is 4x squared minus 8x plus 4 equals 2x. Love that. Now what can we do? I was like, before I do GCF, so hold that thought for just a second. I'm going to subtract the 2x. We're going to make it equal 0 first. So we're going to have 4x squared minus 10x plus 4 equals 0. Now what are we going to do? GCF of 2. So 2 times 2x squared minus 5x plus 2 equals 0. Now what? Divide both sides by 2. We don't need to have it there. 2x squared minus 5x plus 2 equals 0. We're solving. We're not trying to put this into vertex form or factored form. We can get rid of stuff. Now what? Factor. Let's see if we can factor it. So my a times c goes at the top, which is 4. My b at the bottom, negative 5. Is there a pair of numbers that multiplies to make 4 and adds to make negative 5? 2 and 1 will not multiply to make 4. Negative 4 and negative 1 will multiply to make 4 and add to make negative 5. So since I have an a value, we definitely need to use the box. Or split the middle or some other form, but we need a tool. Where I take my 2x squared and my positive 2 from my equation. The x variable is just how we split this middle term. So it's this variable, minus 4x and minus 1x.
Can we work off the negative 1 right there, what it is?
That's totally fine. You'll get the same factors. They're just going to be on different sides of the box. Totally fine. As long as they're in the purple spaces, it doesn't matter which one's where. So what is shared, for me it's my first column, between 2x squared and minus 4x? 2 and x. What is shared between minus 1x and 2? Negative 1. It's always going to have the same sign as this box. We just got to be really careful about what's shared between them. All right, what's shared between 2x squared and minus 1x, my top row? Just an x. And my bottom row, minus 4x and 2. Negative 2. So our factored form here is 2x minus 1 and x minus 2. Like I said, this is the hardest one. So what are my solutions? What are my x values?
1/2 and positive 2.
Ooh, good eyes. So I'm going to take our positive 2 here. I'm going to work through the 1/2, but yes, you're absolutely right. Because we set each of these terms equal to 0 to get our x value. Add 1 to both sides, and we get 2x equals 1. So our second solution is that x equals 1/2, which is absolutely okay. We can have that. It just means we're going to be careful when we go get our y values, because we still got to do that. Like I said, this one is the grossest. So we're going to come back up to the top, and we are going to pick an equation to substitute our values into. You can use the bottom one, but then we're going to have square roots and plus and minuses and gross things. So I'm going to go ahead and use the top one, and I strongly encourage you to do so. So we're going to have our y equals minus 2x plus 2. Yeah. Minus 2x plus 2. I'm just rewriting it down here so I can see it. And we're going to substitute in our x values. Y equals minus 2 times 2 plus 2. And y equals negative 2 times 1/2 plus 2. Substitute in both values. So for my left one, for my blue one, we're going to simplify this. Y equals negative 2 times 2 is negative 4 plus 2. So what's my y value here? Negative 2. So we have a solution of 2, negative 2. Now let's do the one on the right, the pink one. Y equals, what is negative 2 times 1/2? Negative 1. When in doubt, use your calculator. Negative 1 plus 2 is 1. So our other point here is 1/2, comma 1. That one is definitely the grossest of all the ones that we have to do. Okay, questions on these? Because it's a step at the beginning and a step at the end, but all the middle bit is stuff we've been doing. Okay, I'm going to hand out the last homework for the chapter, and it's nonlinear systems. There are 4. Okay. Tomorrow I will have the review for you guys for the quiz that is on Friday. Friday's quiz is Friday. Okay? So you guys have about 10 minutes where you start working on things. Alright, so work on stuff, ask questions, look real carefully at the one we just did, and number 3, you're welcome.